Okay, so now I'll move on to question number 2 in exercise 3B. So we will continue with questions regarding outliers. Okay, so in question number 2, they say the masses of male and female turtles are given in grams. For males, the lower quartile was 400 grams and the upper quartile was 580 grams. For females, the lower quartile was 260 grams and the upper quartile was 340 grams. Okay, look. An outlier is an observation that falls either 1 times the interquartile range above the upper quartile or 1 times the interquartile range below the lower quartile. They're asking which of these male turtles would be outliers, which of these female turtles would be outliers, and what is the largest mass that a male turtle can be without being an outlier. Okay, so the first thing you need to understand here is how it's quite similar to the sums that we did previously, but there is a slight difference. In the previous question, you recall that the outlier rule was slightly different, isn't it? So if you recall, how does the outlier rule go? So this is the rule we use, right? Can you recall? So the common definition of any outlier is any value that is either greater than Q3 plus K times Q3 minus Q1 or less than Q1 minus K times Q3 minus Q1. So this K value will be given in the question. So that's exactly what's happening now in our question. They have told the K value, it was given as 1 times interquartile range. Should you notice that? Okay, so in our question, it was given as the upper quartile. Can you see an outlier is an observation that falls either 1 times the interquartile range. Remember, interquartile range means Q3 minus Q1. 1 times Q3 minus Q1 above the upper quartile. What is the meaning of above the upper quartile? Now we know upper quartile means Q3, right? So above the upper quartile means you add this value to the upper quartile. Can you see? So Q3, you add the K times Q3 minus Q1. Q3 minus Q1 is the interquartile. So K value is given to us in this question as 1. So in the question to question, it will change. Okay. So over here in the question, they have described. Okay. So then let's write the outlier boundaries. So what are the boundaries? So we'll talk about, so we'll calculate first for the males. Part A is about which of the male turtles would be outliers, right? Okay, so let's calculate the boundaries for the males. Okay, so outlier boundary. So what's the upper boundary, upper limit? So upper boundary is Q3, plus, right? Plus 1 times interquartile range, because that's what they say. Outlier is observation that falls 1 times the interquartile range above the upper quartile. Okay. So Q3 plus 1 times the interquartile range means Q3 minus Q1. Shall we do this for the males? I think we know the Q3 and Q1 for the males, right? So for the males, the lower quartile is 400 and the upper quartile is 580. So upper quartile Q3 is 580 plus 1 times Q3 is 580 minus Q1 is Q1 is 400. How much is the answer? 580 plus 580 minus 400 is? So upper boundary for the weight is 760. So this is the upper boundary. Okay, let's also get the lower boundary. So remember, when it comes to this upper boundary, any weight, any person whose weight exceeds 760 becomes an outlier. Understood? Okay, and then the lower boundary. How does the lower boundary go? An outlier is an observation that falls either on 1 interquartile range above the upper quartile or 1 interquartile range below the lower quartile. So below the lower quartile means you should subtract. So below the lower quartile means Q1. So from Q1 you subtract 1 interquartile range. Are you with me? You subtract 1 interquartile range the one value is given in the question. It will change question to question. In the exam, you need to use the value that they give you because they will define how the outlier boundaries will be found. So it's given in the question and you need to use the boundaries that they give. So Q1 is 400. Lower quartile Q1 is 400 minus 1 times interquartile range Q3 minus Q1. So Q1 is 400 minus 1 times Q3 minus 1. Q3 is 580. Q1 is 400. So 400 minus 580 minus 400 is 180 again, right? So 400 minus 180 is 400 minus 180 is 220. So lower boundary is 220. So remember, any value who is below the lower boundary will be an outlier. Okay. So now all you have to do is to test these data points. So look at the data points. So look at the data points. The first data point is 400 grams. What do you think about 400 grams? Is it an outlier or is it between these two data points? Okay, now remember, you have to check whether your the lower boundary is 220, the upper boundary is 760. So anything that is equal to these two values or in between these two values is a part of our data set. Anything bigger than 760 or lower than 220 will be an outlier. So 400 is an outlier or not? No, 400 is not an outlier. Okay, they are asking us which of these male turtles would be outliers. What about 260? No, 260 is also not an outlier. It's between these two values. What about 550? No, 550 is also not an outlier. 640 is also in between, right? I think you can see all of these matches are in between the two boundary values, which means all of the male turtles, none of the male turtles are outliers. Understood? So you can write there are no outliers. Part A, there are no outliers since all data values fall within the boundary. All the data values are within boundaries, so there are no outliers. Okay, what about part B? Which of these female turtle matches would become outliers? Okay, let's do the same thing now for the females. Shall we? So we have to get the upper boundary and lower boundary limits for the females. So what's the upper boundary, the upper limit? So upper boundary is again Q3 plus 1 times interquartile. So what is Q3? For females, the lower quartile was 260 and the upper quartile was 340. So upper quartile is 340 plus 1 times interquartile range is Q3 minus Q1. So Q3 was 340 minus Q1 is 260. So 340 plus 80, which is 420. So upper boundary is 420. And then what about the lower boundary? Q1 minus 1 times interquartile range. So Q1 is, Q1 was given, it was in the question. Q1 was 260. 260 minus 1 times interquartile range is 340 minus 260. Remember, you have to use the weights of the female turtles now. So how much is it? 260 minus 80, right? Which is 180. Okay, and now all you have to do is to check the weights of the female turtles and see if anyone falls outside the boundaries. So what do you have to say here? 170 is an outlier or not? 170, you can see it's lower than the lower bound. So you can say here 170 is less than 180. Therefore, 170 is an outlier. 170 is an outlier. What about 300? Is 300 an outlier? No, 300 is in between. What about 340? 340 is also in between 420 and 180. No problem. What about 440? Yes, 440 is exceeding 420. Therefore, that is an outlier. So you can write 440 is greater than 420. Therefore, 440 is an outlier. Okay, so next let's attempt part C. What is the largest mass a male turtle can be without being an outlier? Okay, so I have the male turtles here, upper boundaries, lower boundaries are found, the limits for outliers. You know, if you exceed these limits, you become an outlier. But if you have the value of these limits or in between these limits, you are totally fine. So what's the largest value a male turtle can take without being an outlier? You can see the upper boundary for the weight is 760. Anything exceeding 760 will be an outlier, but 760 is the largest that we can possibly take, and 760 is not an outlier, but anything that exceeds 760 is an outlier. So what is the largest mass a male turtle can be without being an outlier? Answer is 760 grams, the upper boundary for male turtles. That's it. Okay. Okay, so next I'll be attempting question number 4 in the same exercise. So they say the ages of 9 people at a children's birthday party are recorded. Sigma x is 92 and sigma x square is 128, 1428. So sigma x means you add the individual x values, right? There are 9 ages you have considered, which means you will be adding all the 9 ages. That's what we are doing. And how do you get sigma x square? You square the x value, right? You square the x value and you add. So there are 9 ages you are considering. You square the age and you keep on adding with the square of the other ages. That's what you do by sigma x square. Okay. Question is to calculate the mean and standard deviation of the ages. How do you calculate the mean? What's the formula? So mean equals, when there is only x, we use the equation sigma x over n. This is the equation we used in chapter 2. This is the equation which we used in chapter 2. So sigma x is 92 over n is 9, because they say there are 9 people at the party. So you are considering 9 values, 9 data points. So how much is 92 divided by 9? I think the answer, the fraction simplest answer is 92 over 9, which is 10.22 or 10.2 correct to 3SS. Do you agree? Okay, 10.2 to correct to 3SS. Okay, and then let's get the standard deviation. How do you get the standard deviation? So what was the rule? Again, you need to remember the rules you have done in chapter 2. In chapter 2, the standard deviation rule was sigma x square over n minus sigma x over n whole thing square. So this is the variance. To make it standard deviation, you have to root it. So this is equal to sigma x square is 1428 over n is 9 minus sigma x is 92 over n is 9 whole thing square, and you root it. So it's a matter of typing everything in the cal. So we get here 7.360. Yeah, it goes on, right? Yeah. First, shall we get the value inside the surd? Yeah, so we'll directly get it from the cal, right? So answer is, I think you get a large decimal, 7.36022072. It goes on. So I'll write 7.36 correct to 3SS. All right. Next, let's move on to part B. Okay, so in part B, they say an outlier is an observation which lies plus or minus two standard deviations from the mean. Now look at this. In this case, the outlier definition, they have completely changed it. Now in the previous questions, when we were working with outliers, we calculate outlier boundaries by using quartiles. But now they are saying you to calculate the outlier boundaries by using what? By using the standard deviation and the mean. So how does it go? So basically it's the question that defines the outlier rule. So now you will be calculating the outlier boundaries with respect to the rule that they've given here. So what's the rule? They say an outlier is an observation which lies plus or minus, which means you have to plus and get the upper boundary probably, right? Plus should give the upper boundary, minus should give the lower boundary. So plus two standard deviations from the mean, which means you're adding and subtracting from whom? From the mean, which is our which is the value we have over here, the x bar. Are you with me? Okay, so let's get the, so I'll say mean is mu and this is the sigma value. So let's get the upper boundary. So what is the upper boundary for the outlier? Upper boundary should be the plus case, okay? So from the mean, you have to add two standard deviations. Can you see? So plus two standard deviations from the mean should give you the upper boundary. Minus two standard deviations from the mean should give you the lower bound. Shall we calculate? So mean value, mu value was, you are calculating if the standard deviation is measured from the mean. So you're adding and subtracting from the mean value. Okay, that's really important that you understand when they say from the mean, you add and subtract from the mean value. That's why the mu is written first. Okay. So 10.2 plus 2 times sigma is 7.36. How much is it? 24.92. And the lower boundary for outlier will be from the mean you subtract 2 sigma. So mean is 10.2, you subtract 2 times sigma is 7.36. So you get a negative answer here, isn't it? Minus 4.5. So these are the outlier boundaries. All right, so outlier boundaries are done. And then what are they asking us to do? So they are saying after an outlier is an observation which lies plus or minus two standard deviations from the mean. Okay, so we've made use of that information. We calculated the upper and the lower boundaries for the outliers. That's done. Then they say one of the ages is recorded as 30. Now you know you are recording the ages of how many people? 9 people. So from these 9 people, one age is recorded as 30. Okay, state with a reason whether or not this is an outlier. So according to what we got, and you can see to be within the data set, it has to be lower, less than or equal to this upper boundary, greater than or equal to the lower boundary. So actually, you are getting the boundaries for the ages here. So actually, this negative is not even necessary, right? So over here, what do you understand? The value 30 is definitely passing the upper boundary, which means it is an outlier. So 30 is greater than 24.92. Therefore, 30 is an outlier. 30 is an outlier. Do you agree? Okay. And then move on to part C. Let's move on to part C. They say, suggest a reason why this age could be a legitimate data value. Now, what have we done? You need to understand why this age could be a legitimate data value. You need to understand the question here. What is the question? What have they done? In this question, they say the ages of 9 people at a children's birthday party are recorded. So basically, at a children's birthday party, they expect mostly to take the ages of children, right? But you can see they've taken the age at one age as 30. How can one age become 30 in a children's party? Yeah, it could be a parent. It could be some sort of an adult. So probably it should be a parent. So they've taken the age of a parent here. That's why it was because that's a person who is in this data set, a person who is in the party. So they've just taken randomly 9 people. Is it clear? So why it could be legitimate? Because that's all that could be the age of a parent. Okay. So these kinds of questions to answer, you need to understand the question, like the type of question and the situation that they have presented in the question. Accordingly only you should answer to these types of questions. Okay. Okay. Okay, so we'll move on to part D. Given that all 9 people were children, can you see? Clean the data, okay, and recalculate the mean and standard deviation. So basically, what they are asking you by cleaning is you need to remove the data because they need this to be for this needs to be done for children, right? So they are asking you to clean the data means to remove the unnecessary data. So who is the unnecessary data you need to remove? This age 30 needs to be removed, which means the data set of 9 people will now become 8. So you're going to remove this unnecessary person. Okay, and then they ask you to remove the unnecessary person and recalculate. Recalculate the mean and the standard deviation. Basically, the sigma x over n and sigma x square, these formulas need to be applied again, but for the clean data. So these are things that you commonly get to do in your exam, right? You need to clean the data, remove these things, and again recalculate. Okay, so how do we do this? How do I get the new mean? Yeah, so how do we get the new sigma x? Now, sigma x means you add the ages of all the 9 people, right? So basically, you add x1 plus x2 until the x9th person, right? That's what we do. So we know that the addition of the 9 ages was 92, right? So then what I need to do here is I need the first 8 data values, but I don't want the last data value, which is what? 30. What should I do here? Do you understand that x1 plus x2? I mean, we don't need to write like this. I'm just showing you the last data value here is 30 because you have 9 data values here, 9 ages. So x1 plus x2, I know these, I don't know these ages, but I know they are in the data set. The last data value is 30. So that 30 should be removed. Are you with me? How much is 92 minus 30? 62. So 62 is the addition of the ages of the 8 children, which means what? This is the new sigma x. Can you see? The new sigma x for the 8 data values is 62. The new sigma x for the 8 data values is 62. Are you with me? Okay, and then let's also we need to also get the sigma square value, right? How do we get the sigma square value? How does sigma square value work? You square the individual data points, right? You square the individual data points. That's how you get sigma x square. What was the sigma x square value given for the whole data set? 1428, right? 1428 equals to, so you square the ages of everyone. Now you know that the last data value is what I'm trying to remove. So what's the last x9 data point? That's 30. So then 30 square. And what do? You remove, you subtract 30 square from the other ages. Are you with me? And then I'm remaining with the sum of the squares of the ages of the 8 children. Are you with me? How much is it? 1428 minus 30 square. So 528. This is the new sigma x square. So remember, the new sigma x square is for 8 data values, not for 9 data values. Are you with me? Okay, so the question is to find the new mean and the new variance. So new mean. So new mean is sigma x over n. For the new sigma x value is 62, n value is 8. Do you agree? How much is it? 62 divided by 8. 7.75. That's the age of the 8 children, the average age. New standard deviation. So sigma x square is 528 over n is 8 people now, right? Minus sigma x is 62. So we get here, when you type everything in the cal, it becomes 2.436698. Yeah, it goes on, right? So basically it's 2.4366 or 2.44. 2.44 correct to 3S. So that's the new standard deviation. Okay, is this clear?